Okay. Okay, hello everyone. Welcome to our OpenShift Commons community meeting. I'm Valentina Rodriguez. I'm a principal technical marketing manager in OpenShift, and I'm here with Natale, who will be talking about Red Hat Trusted Software Supply Chain. We meet every Wednesday at 12 Eastern Time. So happy to see you here today, and we will see you next week. So Natale, is all yours. Whenever you're
Hey,
ready.
thanks Valentina for the invite. It's really pleasure to come back to the OpenShift Commons weekly meetings. My last one was on Knative, I think in 2019. Too
Wow.
much, too much far time. I'm glad to come back. Thanks for the invite.
Of course.
I'm also very pleased to talk about supply chain security and what Red Hat is doing in this space. I have some slides, then a quick demo. But if you have any question, just write the question in the chat or jump in the call. I don't know if it's interactive or not, Valentina. But if you have any question, just send a question, and I'll try to reply as soon as possible.
That's great.
All right, so I'll start with the slide. So we set a little bit the context, Valentina, and then we go through our flow. I'll start sharing slides. So advanced, basic. I'm trying to share essentially. Hold on. Okay, so I hope you can see my slides.
If
This
you
meeting
can
open?
make a slideshow.
Yes, slideshow.
Yeah.
There's something blocked here. What's wrong?
Let me pause the recording.
Thanks. So welcome to this session. Today we're going to talk about the Red Hat Trusted Software Supply Chain, which is a Red Hat product suite for supply chain security with open source tooling. I'm really glad to be your guest at OpenShift Commons. My name is Natale Vinto. I'm leading the developer advocates team here in Red Hat, part of the application developer BU. I've been a specialist solution architect for OpenShift, consultant also in Red Hat. I was organizing the OpenShift Commons in Milan back in 2019. And I'm a Kubernetes Community Day organizer in Italy from 2021 to also this year. We had a blast. I know, Valentina, you had also a great KCD in New York. Those events are really cool. And hey, last year I was a CD Foundation ambassador. CD Foundation is a Linux Foundation Linux Foundation Association, which is governing and supporting open source projects for CI/CD like Tecton. And I'm author of those two books, Modernizing Enterprise Java and GitOps Cookbooks. I'll give you the link in the chat, and you can download this and other books for free. Hey, I'm also hosting a show on OpenShift TV called OpenShift TV Coffee Break. Moreover, in EMEA time zone. Yeah, and that's me. Let's go into the main topic of today. First of all, I want to show you also my team. Me and my team, we do developer advocacy, technical evangelism for Red Hat products like OpenShift, Red Hat Trusted Software Supply Chain. The team is globally spread across the globe, as you can see. This is the team. So if you see us at any conference or any meetings, please reach out to say hi. We're really looking forward to meet you. Let me start from after this preamble. Let me start from some numbers. 742%. What is this number? It comes from the annual state of software supply chain. It's a report actually from 2022, so not very up to date, but this number is the increase of attacks at the software supply chain compared to the previous year. So it's an impressive number, and I'm sure this number is also increasing because there are the attack risk is increasing, and the kind of attacks are improving. There's more need to put security in place for the whole supply chain again. Yeah, so in fact, there's a need of increased regulation, framework, directive. For instance, this is in North America, the SEC cybersecurity rule requires more governance and management regarding material cybersecurity risk. There are more government cybersecurity regulation, European Union and United States and also other countries are following. There are more standards, more demand for security. But let's start from the day-by-day work in any IT company, in any company, right? Is that there's a developer and an ops, they work together, but they don't communicate much. And this is a nice analogy of having something to do by Friday afternoon with developer trying to communicate with the ops. And also another analogy, you can see that when you have to push a feature in a software feature or any feature, right? There are lots of people trying to push this, and it's like moving this big stone up to the hill, and you see different people. There's this person pushing back, another guy, another person pushing down, and there's somebody that carry the whole world on their legs, as you can see here. So that's another analogy on a typical workflow, and this is what we call the wall of confusion. When teams don't speak each other in companies when they need to work on project like developer and ops, this is the so-called wall confusion is creating friction, is lowering down productivity. Ultimately, it's making things less secure because there are silos in the projects. So the idea is to break this wall of confusion, making this collaboration really happening. And again, not only for dev and ops, so dev, ops, sec, network, anyone involved in the project, we all need to break this wall of confusion and make things working together. Here's a modern way to see that, if you will. There's the app developer, so there's the dev, there's the ops, security, operations, site reliability engineer. The bottom line could be today the platform engineer, so build the person building the platform, making sure that there's a pipeline like this where you can create software, build, verify, ship, monitoring, manage. You can see there are many steps here, and we will look at those in details. But for each step of software creation, software building, software verification, there's a security step that can be implemented, like from picking the right base image, picking the right software dependencies, and then building and then verifying. Each step can be done in a secure way. Software component decision analysis, software bill of material generation, test, SALSA, which is a standard we'll see in a moment, for ensuring security in the supply chain, software supply chain, shipping, monitoring, managing. So every step has its own part for security, and everything could be standardized on something like Git, on Open Container Initiative. That's what could be a modern way to develop software today. And while developing software, there was an evolution from the classical cloud services model. You remember the cloud pyramid with the infrastructure as a service, platform as a service, software as a service, right? There's an evolution of the platform as a service, which is called a platform as a product. What does it mean? It means that you are managing anything, the platform as a product, but what is a platform under the hood? If we look at definition, the platform is a foundation of self-service, API, tools, services, knowledge, and support that are arranged as a compelling product. And I like to call out this famous image of the iceberg, right? When you see something on top, you don't see what's behind, what's below this level of the sea, the ocean. And you can see here, there on top we have probably a portal. We are opinionated here, saying backstage, but can be any portal. And then we have, some collaboration, developer environment, database as a service, observability, so anything to ease the scaffolding development environment, creating developer experience. Down under the level of the ocean, we have continuous delivery, artifact storage, continuous integration, artifact builder, source control, authorization, authentication are back, and then all the namespace as a server, all the resources, compute, network, storage. This is what you don't see. What you see on top is this experience. And the digital platform is the foundation of those self-service API tools, services, arranged as a compelling internal product. That's why platform as a product. But compelling for whom specifically? Let's look at some numbers in order to reply. Today's customer challenges. Today customer challenges are this one. Application modernization, still in progress, right? Modernizing from monolith to microservices. Rise of generative AI, lots of focus on this, trying to keeping up to speed to Gen AI and AI. Developer productivity, making sure developers can focus on writing the code and then reducing for them the so-called cognitive load. And then, of course, supply chain security, software supply chain security. We have seen this number beforehand. All of this can be addressed. It should be addressed in the platform. But coming back to the cognitive load mentioned, so why developers are facing cognitive load, and why this is reducing the developer productivity. If we look at this historical evolution of software, I'm a big fan of history, moreover computer history. You see that we were from the 60s, and then evolution of programming languages, more programming languages, more platform, up to mostly today when we have cloud, Kubernetes, lots of programming languages, lots of framework, lots of open source projects, which is really cool, but it's also complex to navigate this choice for developers, that they don't have to know everything of everything, right? At least this infrastructural part, it should be below the level of the iceberg, right? It should be provided as a service, provided out of the box by the platform, if you will. And not only that, I put here the picture of Godzilla because it really makes the idea as how much is disruptive Gen AI. So this is something really powerful, but also something that to take in consideration on how to integrate AI to apps, how to make apps intelligent. So how do we make this easier? How do we make this life easier? And how do we make it in a secure way? That's why we're focusing today on the supply chain security. And this space is relatively young. It comes from an existing movement. Of course, you might have already heard about the DevSecOps movement, the DevSecOps manifesto. It's an evolution of the DevOps movement that focuses on security for all the aspects of the automation. And the supply chain security inherits, of course, the government regulations that mandate certain steps to be implemented, and also drive increased security. So it's a relatively young space, but has some pillars that came from the industry from many years. Also, software security is a journey, right? We could start from really basic, and then we can go up to a more granular, a more fine-tuned, and more fine-grained security. But what are the domains of security? At least 4, I might say. So software composition, and we're coming back to the picture we saw before about the app developer, the ops, and the pipeline of the software development. So the domains are the software composition, so the tool and process to understand the software, how the software is being produced with all the dependencies, the component, and this acronym you will see. We'll come back to that in a moment, but you'll see it many times here because the so-called software bill of material is a kind of an inventory of all the dependencies of your software, all the components that you can have for each version, so you can have an inventory of every version that you can scan and make sure that they are all up to date. Scanning is one of the most important domains, so assessing the software composition for potential vulnerability, but also signing, make sure that the software is signed and you can test it, you can ensure the provenance, no? Who made this software, who signed this software. So nobody can inject malicious code unless it's signed. Also, policy enforcement management, it's really good to apply and enforce those conditions at runtime also to comply in order to be used. So those are the 4 domains. And if we want to make a definition in the 3 main pillars of software supply chain, we can express those 3: prevent and identify malicious code, safeguard build system early, and continuous monitoring security at runtime. For the first one, prevent and identify malicious code, if we go back to that pipeline, if you recall, the code, build, deploy, monitor. So for the code itself, we can analyze the software composition. We can digitally sign the code. I'm putting here some open source software in this space, like SigStore, WAC, and also Red Hat product that are helping in this space. Red Hat Profile Analyzer is a Red Hat product that is helping for scanning software bill of material, listing software bill of material, scanning the dependencies, having dependency recommendations, and so on. So start with trusted content, and then we need to give to developers the right tools. Again, a community project like SigStore, popular IDEs like Visual Studio Code, IntelliJ, so the extension of those popular IDEs, and so the combination of this can enforce developer to use the right tools, and the Red Hat product for that are Red Hat Profile Analyzer and Red Hat Trusted Artifact Signer. With this, you can digitally sign the code, the commits, and you can also express the analysis recommendations. And then you move into the build phase. Once your code is scanned, once your code, the analysis composition is done, and essentially also your Git commit are signed, then you move to the pipeline, the automation. For the pipeline, you have the famous phase are image building. So first of all, artifact building. You have a software, you create an artifact. Then you can sign this artifact. You can build a container image. You can scan a container image. You can sign a container image. And for that, Red Hat Trusted Artifact Signer is a Red Hat product based on SigStore. But also, you know what? You can also sign the pipeline execution. Here's another open source project I help in this space, which is called Tekton Chains. Is an extension of Tekton, which is a Kubernetes native CI/CD system. In OpenShift is made with OpenShift pipeline. So OpenShift pipeline are implementing security with Tekton Chains, and moreover, are implementing SALSA level 3 attestation and provenance. So it's possible to sign the execution on a particular pipeline run. This is really cool, and not many pipeline systems have this feature yet. So open source is championing this part. But also scanning, and you can use the open source like Claire, and you can use Red Hat Quay as a product to scan the container image. But for the policy enforcement and runtime, also the Red Hat Cluster Security for Kubernetes. In fact, policies, verification of policies at runtime, deployment. I put here again some open source tooling like Argo CT for deploying the application, and making StackRox and advanced cluster security for Kubernetes for making sure that the policies are enforced, and also this project called Enterprise Contract to verify the SALSA level compliancy after the pipeline has been deployed. So this tool can also verify if everything is compliant to the definition. And last but not least, the monitoring. So we need to keep monitoring security at runtime, and for that there are open source projects. There's advanced cluster security for Kubernetes, Prometheus like metrics for and other things. So those are the main pillars, if you will. There's with open source project for that, and also Red Hat products. And here's Red Hat product suite. Red Hat Trusted Software Supply Chain is the product suite containing some product like Red Hat Trusted Artifact Signer, the one which is using SigStore, if you are familiar with that. Red Hat Profile Analyzer, the one for software composition analysis. And then also an internal developer platform, talking about platform, platform as a product. Developer Hub is an internal developer platform providing an internal developer portal. And this product suite is called Red Hat Trusted Application Pipeline. Everything running on OpenShift, and in combination with Red Hat Quay and Advanced Cluster Security for Kubernetes, this create a product suite. So that's the product part. Let's go into the community part. The security, as we quickly mentioned also for Tecton, right? Tecton is one of the first implementation of pipeline attestation and provenance in the pipeline. And the security begins with community. The open source security is built. The open source security is built upon thriving open source community like yours, like this one from OpenShift Commons, for instance. But at the end, what are customers interested in? What are also community interested in? If you ask the expert in the sector, image vulnerability, content signing, policy enforcement, we mentioned this and also in the 4 domains, but those are the most eaten question, if you will. And again, on terminology, if you haven't yet seen that, like SALSA, supply chain level for software artifact, is a set of standards that ensure that you are building a system with a certain level of security, and the number will express this level of security. I'll show you in the next slide. But also other terminology like CVE, common vulnerability and exposure, provenance, attestation, software bill of material. You'll see lots of this terminology on from now going on. But for SALSA, which is a standard, you have different level. The level 0 essentially is the no security, is like a dry run. But then you go up to the level 1, level 2, level 3. It means that this is providing a more comprehensive security level. In fact, the level 3 prevents run from influencing one other, prevents secret material used to send provenance from being accessible by end user defined step, prevent tampering during the build. So it's really important to achieve the maximum level of security, and SALSA level 3 is the one that you can you have out of the box with that product suite. And that's also the approach of the shift left. You know, if we look at this pipeline, from user to the pipeline, coming back to the developer, and the code, a shift left approach will help in achieving this standardization on security. And if we look at this pipeline and we want to mention open source tooling, this is Red Hat opinionated way to implement it, right? Kubernetes, so OpenShift, and Argo CD for deploying, and then StackRox, and then Claire, and then Quay, SigStore, Tecton Chain, and any Git server. But that's the Red Hat opinionated way to combine all these open source projects and then productize that. And those open source projects have also a big community, some really cool communities. If you go to conferences like the one from OpenSSF, the open source summit, and then other conferences for security, there are more and more coming on, more projects like SIFT, WAC, Enterprise Contract itself. So there is an opportunity to influence also this community with more use cases if you want. We mentioned Tecton. There isn't only Tecton, of course, but also others are coming in the SALSA compliancy, GitHub Action and Jenkins. There are others popular CI/CD system. It's important to have It's important also to put security in this part, and if possible, to have provenance and attestation also on the pipeline execution. For the signing content, it's important to understand what do we want to sign, how do we sign it, and when do we sign it. Well, we want to sign, as we understood beforehand, the artifact that we're compiling, the container image that we're creating, and then any supplementary artifacts like additional asset for the software bill of material. So this is what we would like to sign. How do we sign it? It depends on the system we're using. SigStore is supporting many ways to sign artifacts, sign content. So it could be self-managed, it could be with a key management system, or either a hardware token. One of the coolest one is this one, a keyless signing. You are using an OIDC, and you are essentially you can take benefit of the OIDC to create a keyless signing. I'll show you quickly in the demo how we can do this keyless signing with SigStore, Fulsio, and so Red Hat at the Trusted Artifact Signer, and Kicklock, so the single sign-on that generates short-lived that will use the short-lived key pair generated by Trusted Artifact Signer. So this is one cool way to sign content. And let's look, before going into the demo, let's look at this generic development process, right? We have coding, building, deploying, monitoring. So we have our dependencies, our application, our base image. Then we do a git push, git commit, git push. And then the pipeline start, right? The pipeline start with all the steps that create the container image, and then the deployment with GitOps most of the time to the target platform like Kubernetes, and then we start with the monitoring. This is generic. How about a security augmented development process? We put SigStore in place, and we put also the other tooling in place. So we can add security at each step. For instance, for the code part, we can use Red Hat Dependency Analytics, which is an extension for popular IDE that can scan dependencies before we start the pipeline. I'll show you in a demo an example of that. But we have our software code base. We analyze our dependency file. For Java is a POM XML, and then for other programming languages, requirement 60 for Python, Go mode for Go, whatever. We analyze the dependency locally. So we'll try to fix those before starting the pipeline. We have our base image, right? So if we can control that, we can also decide to make some change. But after that, we can sign also the commit with SigStore, and so for Red Hat is Trusted Artifact Signing. We sign the commit, and then this commit can kick off a pipeline. This pipeline can verify if the commit is signed. If not, it can stop. And then it will also sign the container image, also generate the software bill of material, also make sure that the pipeline, the build provenance and attestation for the pipeline are valid. Scan the container image, store the container image, and then for the deployment, we can also verify the SALSA compliancy when on this part. Well, imagine this is a pipeline that sends everything to a dev environment, but when we want to move to a pre-prod or prod environment or whatever environment we're considering, we're verifying if this is compliant to the standard. And this could be an additional step. And then we can enforce the policies at runtime, deploying everything on Red Hat OpenShift, and then making sure that the advanced cluster security for Kubernetes is enforcing policies, and having also this BOM file in Red Hat Trusted Profile Analyzer give us a great pipeline, a great chain, really a security augmented development process from code to prod, if you will. So that was the theory, and I think we have time now to go into a quick demo showing you this in action. For that, I need to, Valentina, I want to check if there's any question in the meantime, and then I'll share my whole screen so I can show the whole demo.
Not in the chat, but I invite if anyone has any questions you want to ask right now.
Um, I love your presentation, and I think your security augmented development process is just as important as the as teaching the waterfall process and the agile. But I'm trying to think about how do you do the workforce training to get the new developers and the new workforce up to speed on this.
Hey, that's a great question. How do we put that in place so that we're not giving cognitive load to these developers? How do we put that in place? Likely, how do we automate all this and make it easier for developer? This is what I wanted to show you now in the demo. So how do we make all this in place? And I wanted to start from a real world application. Let's say I have here, this is Red Hat Cool Store, and it's a microservice-based application. Let me know if you can see my whole screen. I think I'm sharing the
Yep,
screen right now.
we can see the topology
Okay.
view.
Good. So this is an OpenShift cluster. This is an application with 4 microservices, and this is Red Hat Cool Store, right? So imagine we need to work on this one, and we need to do a change on one of these microservices. I need to ask the developer of one of the microservices to make the change to fulfill the quantity of Fedora. We cannot have not in stock Fedoras. It's not possible. Let's fix it. How do I make sure that developer are putting the right base image, the right dependencies, and all this chain of signing it's in place automatically for everyone? Of course, it's an opinionated thinking, but for Red Hat and the community on that, we think that an internal developer platform can be the great way to start all this. Why? First of all, it's a single pane of glass, and here you see Red Hat Developer Hub, which is Red Hat product behind Backstage. So essentially, this is a Red Hat product for Backstage. This is a Backstage view, and so we're asking developer to log into this to start their journey. But where is security over there? First of all, we need to we can say that the developer hub and Backstage is great as a software catalog. So if I have something deployed like this application is deployed, and I can see something like a relation graph, so I can see, okay, this is my application, this is my front end, there's an API which is using this other component, there's dependencies, and I have all the list of those are the microservices, those are the API with the documentation. So that's a great way to start from an architectural point of view. But how do we put security? Well, the security can be put on the so-called software templates, in terms that we are asking developer to use a platform and a portal. They log in with the favorite authentication system. It can be federated to OpenShift. They're using OpenShift. This is, for instance, this is deployed in OpenShift with an operator. So if they have to start and make a change to that inventory service, for instance, we're asking them, hey, go here and order a copy of the inventory service. You want to do your test local, no? Or do a copy and deploy to a certain namespace like this one, and then put the host name of the class. So those can be pre-built or can be also as an input for developers. For the security of the registry, use the internal registry or use Quay.io, and this will create again automatically the host name, or it can be modified at convenience, like I'm doing here right now to you. What I wanted to say that we're putting a skeleton of the whole project with everything in place, and I'll show you how it works. Because if we do this and we also say, okay, for this demo, we're using GitLab. It can be Bitbucket, GitHub, whatever you want to use. Do you want verification of commit, yes or not? So we're asking to developers something, and then they can review everything here, and then they can order their environment. It can also be seen like a namespace as a service, right? They can create a namespace. They can put everything there. What I mean for everything, if I open this view from the Developer Hub and Backstage, I can see that, okay, this template has created the source code of the application I need to modify. There's a source code, there's a Docker file, there's a POM XML. As a platform engineer, I'm preparing this template and I'm preparing a skeleton of this app, and I'm preparing the so-called GitOps repository. So not only the repository of the app, the repository of the pipeline automation for the app will be created with all the pipeline definition, with security, external secret, config map, whatever. So I'm starting from a template, but this will use a skeleton for the app itself and for the pipeline. So the security pipeline is there. The right dependencies are there. The right base image is there. And I want to show you this on an already deployed environment. If I think I'm drawing something here. Sorry, I didn't want to draw anything. I don't know if you see a violet arrow.
Yeah, but don't worry.
Sorry.
Yeah.
Sorry about it. I don't know.
We need more color in our lives. So
yeah, let's see it. Okay. So let me go on a already deployed one, because I want to show you how do I make that change of the Fedora. This is my already deployed environment. This is my source code, and this is my already run pipeline. The already run pipeline starts from a definition that it's already available. So the automation has created this pipeline. The pipeline are all the steps like verification of commit, the scanning of the image, creation of software bill of material, advanced class security, deployment check, export of software bill of material. This for the CI part. For the CD part as well, there's a one-to-one mapping with and every environment has been deployed in the right way, because somebody has defined that. Now, how do we start from scratch all this? Let's imagine, okay, now we need to make our change. First of all, we download the source code, right? We clone the source code, and then let's say we clone the source code locally and we make our change. I already cloned this code, and I want to make this change of fulfilling this Fedora quantity. This is the Java application, a Quarkus application, so I can test right now the quantity. I can do my changes, right? I know that I need to fulfill the quantity from here, and I'll make sure that I increase the quantity of this Fedora, let's say to 10, and I'm running the test locally. Now, before running any pipeline, I want to run the test locally and see that my changes are good. So also this is part of the so-called inner loop and security loop. If the tests are fine, in this case are not fine because I'm not updating the test, right? When the tests will be fine, then I'm ready to push everything. I'm ready to push everything because I'll start again the test, and then I'm using this developer mode in Quarkus to check that everything is fine. For instance, in Swagger, I can check that now this is my API, and I'll test live that this is working out. I just want to give you the full experience live, of course. So I'm executing this, and I see that the quantity now is 10, so this is fine. Now, from a code perspective, this is fine. What about if we scan these dependencies here before sending to production, before sending to the pipeline? If I perform this dependency, Red Hat Dependency Analytics repo is an extension that you can download from your favorite IDE. And like for Visual Studio Code, you go into Preferences, Extension, and you look for Dependency Analytics. Dependency Analytics. You install these dependencies. This will provide you a scanner for your dependencies. So here I'm using this version of Quarkus. I'm using those libraries. What about if I perform a scan? I already did the scan to save time. The scan essentially will contact the open source vulnerability database and will give you some check on the vulnerability. Look, I don't have any direct vulnerability, but I have some transitive vulnerability here. What about if I try to update the version, just the version of the framework. Right? Instead of using 3.8.1, I'm using 3.11.0, which is another more up-to-date version of Quarkus. What about if now I'll start the scanning again? You see, when you do some change, this extension it makes an analysis automatically in progress, and is able to also recommend you different version. Right now here I'm not using any specific version, so it's going to the latest and greatest to the component. But if you are pointing to some version, it's also suggesting, hey, don't use this version, use this other version, whatever. If we start the scan again, and we can do it in this way, we can close it here and run the scan again. This will likely give us a better scan, because we're using a more up-to-date version of the framework. So we will likely reduce the vulnerabilities. And that's one part of the first part, the trusted content. If you remember the first part of the code. As developer, we have the right dependencies, but we're also helped by this extension. Hey, what about if we want to pre-install this extension in IDEs? If we're using things like OpenShift Dead Spaces or those in browser IDE, we can fully automate this installation. But look at this. That we don't have any vulnerability right now. I want to show you also this before we kick off the pipeline. The first run of the pipeline I did to run the app show us some vulnerability here. Not much, but we have 0 important. If we look open this view from advanced cluster security, we have some high vulnerability, but we don't have any critical. If we ever want to reduce that, how can we do that? We can work, because here we're working on the dependencies. What about if we work on the base image, right? We inherited some base image, which is here. Okay, this is OpenJDK, this version, and this comes from Red Hat Universal Base Image. If I go to Red Hat website and I look for OpenJDK, I see that there's a newer version on Universal Base Image. So this is Universal Base Image 9, which is based on RHEL 9. So I can use an updated operating system layer, an updated version of the base image. What about if I also update this to 20 and I use UBI 9? And let's see if this also improves the pipeline scan. Look, everything looks fine here in terms of changes. We're changing the quantity, we're changing the base image, we're changing the dependencies. And you know what? We can also we can decide at this point to make another version. Instead of 1.0.0, we can have 1.0.1, and because we're updating the version. So let me also update this, bump to 1.0.1, and at this point I want to kick the pipeline, but I also want to sign my commit. How do I sign my commit? I'm using cosign. Cosign. In this case, I'm using SigStore and Red Hat Trusted Artifact Signer to sign my commit in a keyless way. So I'm using SigStore Fulcio, and this is with my user. Which user? The user I'm using on OpenShift, the user I'm using on Developer App, in order to do this signing. So here I signed my code. Then on the IDE, if you are using SSH, of course it will go through. In this case, I'm using HTTPS because in this cluster SSH is not open. But long story short, I just signed the commit and I have automatically kicked off a pipeline. So the software template automation is also creating everything. The webhook to start this pipeline. It is creating also the part where it can also pre-install the extensions. It can pre-configure the authentication to the Git server. If you are using things like dev spaces, when you started, everything is already configured and you can do everything from there. And again, it's running the unit test again, static code analysis, building and signing container image, uploading the software bill of material on Trusted Profile Analyzer. Now, this pipeline will take some seconds. I'll take this opportunity to show you all the steps of the pipeline because I was already running that. So I'm expecting at the end of this pipeline, we have less vulnerability because we updated the Docker image. We also updated the version of the framework with more up-to-date dependencies. How do we look everything here? One thing to look at it is also this one. It's a Trusted Profile Analyzer. The pipeline will update the so-called software bill of material here. And in fact, once you updated it, like I was doing that, you can see it from here. So this is our software bill of material. Those are all the packages listed. Look, the software bill of material is exported in this format, cyclone.dx. It's a big JSON file. You can download it from here again. It's a big JSON file that contains all the dependencies for your application. You can see here in this really big file, which is not well formatted. Sorry about it. It could be indented better. But you can see it's a JSON file with all the dependencies listed. And this is important because for all the software here, you can perform the dependency analytics report, again, also from here. And you can see that from the container image, we've seen some direct vulnerability. You can have any related advisory, any packages. So this was all before our change, the software bill of material before our change. But you have also an inventory of this, and you have also an inventory of existing software bill of material, bill of material. So that's a good thing to have regular Trusted Profile Analyzer to help you having this inventory of your dependencies or existing one like a universal base image, other base image that you are considering in your pipeline. When you're signing the pipeline, you are using Sigstore, so Red Hat Artifact Signer. I want to show you that when you sign the container image, in this case we're using Quay, but when you sign the image, you are signing for a particular version, and any commit goes to latest. So we're sending this to latest. But this tick that you see here, it means that the container image has been signed. Signed with the key the provided. So the signature it's done with Trusted Artifact Signer and Sigstore in this case, but you can make sure that this signature was made by you because you are created the whole stack, you are using this tool. After the signature, of course, it started the scan of the container images. We have seen different scan. There was the scan of the dependencies, and then there's the scan of the container image. And you have it from Quay here, but you also, when you're using with advanced cluster security for Kubernetes, you have it from here. So you have all the issues find with the severity for the image check, for the image scan. So advanced cluster security for Kubernetes can give you all the details that you need. But so far, for the image scan, we had the information from Quay. So you can see here for the layer, for the packages. Those are the advisories. This is fixed in this version. That's why I wanted to update the version of the base image to improve this one and show you that we can also influence that. In fact, our image, it's okay. Because why is okay? Well, because we updated the base image, and Red Dot here was saying that the health index of this base image is A. If we look at security, this image doesn't have any unapplied critical or important security update. In fact, Quay is telling us that from a security point of view, that Docker file base image fix was a good thing because now we're up to date, we're good. And also, I'm sure that in fact we don't have any critical important, we just have any medium and low. Again, we can all see that more in detail in the moderate one in the ACS box here. We improved the scan of the container image. We improved the image check. From a deployment check, we're not violating any policies for building. We're not violating any particular policy. So this deployment looks good. And in fact, if we go to OpenShift and we check that if the application is behaving correctly, now that we updated the quantity, you see that it's number 10. So we could do at ease a fix needed on a, let's say, complex architecture, microservice-based architecture. We're putting all the security in place thanks to Red Hat Trusted Red Hat Trusted software supply chain, and also we could automate everything and make it easier for developers. As a developer, I just test my stuff locally, do my code change, scan the stuff locally, right? And also make sure that the pipeline is also making the scan, and the integration of Quay, ACS, Trusted Artifact Signer, Trusted Profile Analyzer is creating a secure environment for me. And I want to show you also this. Also, the pipeline execution is signed. With this, we are inhibiting or making difficult injection of malicious code at the build time, at the pipeline, because also the pipeline execution is signed. This is a feature that Tecton chains provide out of the box. So to reply to your question, how do we make sure that, how do we make this up and running? A software template with Developer Hub and Backstage, and putting so that need to be maintained, of course, but this really create a great experience for developers that, they just have to focus on the code. They use this for checking any documentation, like, oh, those are the API I need to work with. Those are the services. This is my documentation is here. Everything it's there. Any dependencies, either the image registry with all the scan. I can have a viewer here. I don't have to access OpenShift. I don't have to access Quay if I don't want to. Also, the famous OpenShift topology view is over there. So I can see that my application are up and running in one or more environment. And that's one way to do that. For another way, how do we, to finish this demo, how do we, okay, this is cool. How do we do promotion across environment? This was dev, what's easy? What about, we need to move this to prod, pre-prod, whatever. Again, it depends on how you define the process. In this demo, it is defined with a tag. Remember, we created the version 101, so we can create a new tag, 101, and this tag will invoke another pipeline, which is not the build pipeline, is the promotion pipeline. The promotion pipeline is invoking the so-called verifying enterprise contract. So it's verifying the Salsa level 3 spec implementation for the and compliancy for the environment here, and if everything is fine, then it's promoting it's tagging the container image, and it's promoting the container image in the other environment, which is pre-prod. Then if we want to go to prod, we can create a release, and then the release will go into the prod environment. It's just an example, to be honest, but it can be one way to make sure that there's some release manager, let's say, that some manual process to really send stuff up to prod, and using a enterprise contract project really help us making sure that also in those environments we're compliant to a certain level of the Salsa specification. Yes, so that was the demo, real world demo with the live demo, moreover. So this will dev and pre-prod and prod. The pipeline will go through, and I'll show you that for instance for pre-prod it went through. So this is the other environment, and we have 10 items for sure also over here. So we're promoting the image in a secure way. If we go back to Quay.io, I'm sure we can see that all the other tags have been scanned and have been used in the same manner as we discussed. Yep, I know it's a long demo, sorry, Valentina, but just wanted to show the whole flow and make sure that every point we discussed in the slide were touched.
No, it was fantastic. Thank you so much. It's great. As you know, I am a fan of Developer Hub. So for me, and if you start thinking as developers, how we can ensure that all developers in a company can really produce all the software with all the security guardrails and the company guidelines and best practices. So seeing this demo, it's really a nice way to look into that. So thank you for that. I think there is a question. Are there any Red Hat labs to learn this?
Well, we have labs. We don't have let's say inter external labs. Like we have lots of labs on this portal called developersredhat.com/learn. We have labs for trusted software supply chain. We don't have yet the labs, but we'll add those labs very soon. If you are a Red Hat customer or partner, you want to see that in action, then we can run those internal labs. The one I was using, it's an internal labs. But for the external labs, for anyone on internet, we're building on that learning portal I put in the chat, and also put the link for our ebooks available for free to download. There's one ebook talking about supply chain security, so it could be a good start if you're interested to deep dive more on this topic.
That's perfect. That's great. Any other questions for Natale? No? Okay. Well, thank you so much. This was fantastic. It was so great seeing you and having you here. Yeah, so everyone liked it. So thank you so much. We stay in touch. Thanks, everyone. The video will be uploaded today by the end of the day, and we will be sharing additional materials on our Commons Slack. Thank you. Have an amazing day.
Thank you all. Bye.
Thank you.